Acid-base titration and equivalence point. Titration. This is a method of determining the concentration of an acid or base in a given solution. This is also a type of stoichiometry, as it's reliant on quantities between reactants and products of a substance. The solution that has a known concentration is called the titrant, and the solution with an unknown concentration is called the analyte. A special piece of equipment called a burette is used for this process, and allows the volume added to be measured accurately. The order of which adding an acid to a base, or a base to an acid, whatever it may be, is interchangeable depending on what you're trying to do. The equivalence point is the point at which enough titrant has been added to neutralize a solution. Now, to recognize when we get to this part of the process, we use something called an indicator. This substance will change color when we reach the equivalence point. This point is recorded on a graph called a titration curve. This is just a really poorly drawn graph for this, but we'll set the pH as the dependent variable and the volume of titrant needed, so it's usually measured in milliliters, as the independent. So Y dependent, X independent. In the case of having an acidic analyte, the equivalence point of the titration curve is plotted when enough base or titrant has been added to neutralize solution. Let's say it's right here. Obviously, an actual titration curve would look a lot different from this. This is just a really poorly drawn illustration. So, yeah. Before I show the next clip of me drawing out the second graph, I need to make you aware of the fatal error I made. I pronounced polyprotic as polyprotic for the entire thing. Don't know what went over my head about that, but I'm pointing out that I'm wrong, so you can't make fun of me for it. In some cases, there may not be just a single equivalence point, there may be multiple. In the case of titrating a polyprotic acid, such as sulfurous acid, sulfuric acid, or phosphoric acid, it could look something like that. That would be a diprotic, which would be sulfurous or sulfuric acid. I forgot how to say the first one. In the case of 3 different equivalence points, it would be something like phosphoric acid, which would be triprotic. This is because when a strong monoprotic base is added to the analyte, it's neutralized in different stages of deprotonation. So Ka, I already have Ka1, so Ka2, and so on. Strong acid plus strong base titration will have a pH of about 7, but if the order varies, like strong acid plus weak base or so on, it can be either below or above a pH of 7. For the next video, I'll get more into what Ka means, and like pKa, and I'll get into the Henderson-Hasselbalch equation as requested. So that's about it. See ya.